Hello, welcome to Waka Breaking It Down. This is AP Statistics 2002, number 4 question. We're talking about commercial airlines, and we're making a regression model between number of seats on the airplane and the operating cost per hour for the airlines. Right away, like I can see this is one of those problems where we have different groupings like this looks like a different group than this group and then looks like this group. So as I get into the questions, I'm going to be looking for that idea that um, this is one of those situations where I should be splitting the domain. Um, they put one model on the whole thing, but in reality, these probably are like, oh, these are small planes and these are kind of medium-sized planes and then these are large planes. And actually, like within each of those groups, this one maybe goes up or is kind of flat because it's just 2 points. But this one obviously goes down, and so does this one as you look at those groups separately, right? So I'm sure as we get into it here that you'll be having to talk about that. But let's look at some of the details. So we got a regression model, 12 aircraft. This is important. Like they tell you, it starts at 216 as a small one, it goes to 410. That makes me think that they might be asking me to do a prediction, and I have to keep in mind that I can't extrapolate. So I can't really use any model that's outside that domain, right? So that comes to mind when I'm reading this, although we actually won't be doing that on this problem. Um, and then they give you the range too. So they're giving you some idea of your domain and range, give you some values. Okay, and then they give us a regression output, which is where we need our stuff, and then the questions. Okay, so I can see the explanatory variables there, seats, which you can see on the graph, but sometimes they don't give you the graph, right? So whatever is listed here is your explanatory variable. My response then is the cost per hour, operating cost. That's the slope that goes with that explanatory variable, and my y-intercept is 1136. So that's what I need for my first question. What's the equation of the least squares regression line that describes the relationship? Define any variables. So let me jump right to the equation. You can see they're going to use the 1136 and the 14.673, right? 1136, 14.673. Those are in there. The 14.6 is the slope. They put in number of passenger seats. You see how they write it all out? If you use x separately, like an x on the side, you have to define that. So I usually will just put it right in the problem in the equation. That way I don't have to write it like write an x and then define the x. That's kind of a pain in the backside. So it's easier if you just avoid that. They put in the predicted cost. That's your response variable. To me, they honestly are missing the hat. They need to put a hat on this. They put it on down here when they did y hat, but they didn't put it on up there. I would put it on. That's for our test. That's required. Okay, that shows what you're predicting, right? Now, I guess here's what it is. Instead of putting the hat, they said predicted. That's what's going on. So I can have the hat on the cost and not say predicted, right? If I don't put the hat, then they say the word predicted instead of the hat. Sorry, that's exactly what they're doing. So they are putting the hat on it in a sense. Okay, let's go to part B. Let's read it first. Sorry. Okay, so what is the value of the correlation coefficient? Well, they give us r squared. Again, don't use r squared adjusted. That's for multiple regressions, which we are not doing. So look at the r squared. That's your coefficient of determination. We can take the square root of that to get r. But the one thing, when you take the square root of this number, it's already been squared, right? So it's automatically going to be positive. When you square root it, you have to decide whether it's supposed to be positive or negative. That's a really important point that a lot of people forget. So you have to look at your slope because the r and the slope go together. The slope comes from r, right? When you do z-scores and stuff. So if my slope is positive, that means my r is supposed to be positive as well. So you'll see here in part B, they take the square root of that number. They get 0.755 for the correlation coefficient, and they go ahead and make it positive, right? They're very clear about this needs to be positive. And that comes from the slope along with the square root of 57. Okay. So we got to interpret that though. Finding it's one thing, but now you have to talk about it. So what does this mean? We usually say any R value that's below zero point 0.4 is pretty weak. Anything above zero point 0.8 is strong. This is right on the borderline. So I might say something about it being moderate to strong. If you say moderate or strong, you're going to get it right in this case. But for me, I would say, oh, it's kind of moderately strong, positive, linear relationship. Now, the linear part doesn't actually come from R. It's just these two things that you have to have. The linear would be another condition that you have to kind of match, and that's a separate thing. So you have to say moderate to strong or something like that, and then you have to say positive. Those are the two things you get from a correlation coefficient: the strength and is it positive or negative, slope, right? Okie dokie. So that gives you an idea on part B. All right, let's take a look at part C. Here's the piece where we're going to have to start talking about those groups. Suppose you want to describe the relationship of the seats and the cost, but you're only going to use the range 250 to 350 seats. All right, when I look up here, there's 250, there's 350. So just like I said, they're going to just be looking at that group in the middle. So if I'm just looking at that group in the middle, I'm going to have some kind of association like that, right? It's going to be a negative association. All right, so does the line shown in the scatter plot still provide the best description? Well, no, we need a new model for just that data set. We're going to have a negative association to begin with, and it just doesn't, like the one they gave us that goes this way, just really doesn't represent that data. And so that's what you want to talk about. Let's see what they wrote. Whoop, too far. Make sure you say no. That's important. You can't just go right into it because then it's not clear to the reader whether you say yes or no. The equation of the least squares regression line is influenced by the 3 points on the upper right and the 2 on the left. So that's exactly what I would say. I'd be like saying something about, it looks like there's 3 groups going on. 1, 2, 3. This is the middle group. The regression line is being influenced by all the points, when really we just want the ones in the middle. Right? So that's what they're saying. The 7 remaining points, the ones in the middle, would have a negative correlation, and I would make sure I say it's negative. Hence, the slope of the least squares regression line, the new one, would also be negative. And that's the most important thing. The new slope is going to be negative. The middle group is not represented by that previous regression model. Okay, that's it on number 4. Pretty quick and easy, but you do need to recognize this is one of those split domain questions, right? And you need to know how to, little details about the positive, negative on the R value when you take the square root, and be able to quickly get your slope and y-intercept as well. A lot of questions will ask you to define the slope, or define the y-intercept, or define R squared, right? So maybe I just say it real quick just for practice. So here we go. Let me do the slope first. So for every increase of 1 seat in the airplane, the model predicts, or on average, the cost per hour of the operating cost per hour is expected or predicted to increase by 14.67, right? What is this, dollars? Must be dollars, I'm assuming. Yes, dollars. Okay, so that's the slope. You have to say, like, for every 1 increase in the x, then the y is predicted to increase by this much or decrease. What about the y-intercept? Well, if we had a plane with 0 seats, which doesn't make sense in this context, but if we did, the model would predict that on average, the operating cost would be 1136. Now, maybe it makes sense because whether you have a plane or not, maybe you have to pay for the taxes at the airport, or the parking spot for airplanes in general. So maybe it makes sense in this context. If I interpret R squared, that's the coefficient of determination. I would say that 50% or 57% of the variation in the operating cost per hour can be explained by the association with the number of passenger seats. The rest of the variables come from other things, labor costs or taxes or something else. I don't know. It's not my job to figure that out. But yeah, you really got to say that first sentence, and then you're good. So that's how you'd say those 3 values if you were required to. which happens a lot. So be ready for it. All right. Good luck.